These are the frequently asked questions for pre-calculus for section 5.5 day 1. Starting with number 19, it says in exercises 19 to 22, two triangles can be formed using the given measurements. Solve both triangles. And I guess I'm kind of upset that they told us there's two triangles here. I mean, that's something we would want to investigate ourselves anyway, so I'm still going to do that. I'm going to show the mathematical proof that we get two triangles. So we start this way. We say that we have angle A, and since they said there's two triangles, you know, like I said before, we know to set this up by angle side side. So there's our angle, and opposite angle A is going to be side A, and then we need to know where to put the 17. And again, because they didn't specify, we would definitely set this up as angle side side. So the 17 would go right there. Now, if we don't know that this has two triangles, here's what we do. We have to figure out the height. And to do that, we could just use some good old-fashioned trig and say the sine of 64 degrees equals h over 17. So 17 times the sine of 64 degrees equals h. And that would give us approximately 15.279 for the height. Now that means that our side length of 16 is longer than the height, so that guarantees one triangle. However, it is shorter than the other side, and so that means it will, if it were to rotate, it will hit the base of that triangle again, and it will form two triangles. So because A is greater than H, but B is greater than A, we do get two triangles. All right, so away we go. Now, going back to the triangle, I see that I have the sine of 64 over 16 as one side of the proportion that I'll need. And I realize, well, this is going to be capital B, and this is obviously going to be a pair of C's here. And the only other information that I have at this point is that B is 17, so I have to figure out what angle B is before I can do anything else. So I would cross multiply, and that would give me 16 sine of B equals 17 times the sine of 64. And I'm going to go ahead and do all of this in one step here, because I'm sure you're about at that point too, or if you're not already, you probably are. So 17 times the sine of 64 divided by 16 will give us the sine of angle B. Now we're looking for angle B, so that means we require the use of an inverse. Those inverse buttons are specifically for giving us the measures of angles. We're working backwards from the ratio of the two sides. So we have all of that, and we punch that into the calculator, and absolutely make sure you're in degree mode. That comes out to 72.740 degrees. Then we would know that every triangle has 180 degrees in it. So the measure of angle C is going to equal 180 minus the 64 degrees they already gave us, and our answer for the measure of angle B. So the measure of angle C comes out to 43.260 degrees. Now, we need to find the length of side C, so we'll go back to our first proportion, and we're going to continue to use this because that was flat out given to us. But now, to set up the second part of our proportion, we're going to have to trust that we did some math right and say, all right, I'm going to need the sine of angle C, which I just found to be 43.260 degrees, and I need that over little c. And then a little cross multiplying again, so 16 times the sine of 43.260 divided by the sine of 64 degrees will get us little c. And little c is approximately 12.200. And then, like I had mentioned in class, and yeah, I know it's a little extra conservative of me, but I always just stop at the end and take stock of the fact that, hey, did I solve this triangle? Do I have everything I need? And they gave us that the measure of angle A was 64. We found the measure of angle B. We found the measure of angle C. And little a, that one was given to us, that was 16. Little b was also given to us, that was 17. And then we went ahead and found that side length for C. So 12.200. That's just triangle number 1. Because what we have to go back and do is envision a triangle where, again, our side lengths have stayed the same, but it did actually rotate. So let me go ahead and show you what I'm talking about here. So this side length, because it was longer than the height, rotated and formed an intersection at the base of this triangle, and that will form a second triangle. So this is now the triangle that we need to go after. And again, because I don't necessarily want all these A's and B's and C's to be the same, I'm going to go ahead and use subscript notation for this. And we'll call this C sub 2. I was just thinking about the fact that some books will do that and use the prime for that. And then we'll still have our A, B, and C. But we could certainly put little subscripts of 2 on those as well so that we know that we're talking about a different triangle. Now, here's the key that we talked about in class, and that is if we go back to this sketch, because these two side lengths are the same, we have an isosceles triangle. And in an isosceles triangle, the base angles are congruent to each other. So we said that the measure of angle B was 72.740. So if we want to figure out the measure of angle B sub 2, we need to subtract it from 180. It's a real easy fix, but you have to see it. And so the first thing we would do is say the measure of angle B sub 2 is 180 minus 72.740. And like I talked about in class, I'm kind of ultra conservative, so I went ahead and typed back in all the information that we had for angle B over there so that I could have it in my calculator as perfect. And then the measure of angle B sub 2 to 3 decimal places is 107.260. And then, of course, we know every triangle has 180 degrees, and we were already given angle A. That was a part of the first problem, so this is 64. We know this angle now, which is our B sub 2, and that one we have at 107.260 degrees. And so we can take 180 degrees and subtract those two, and that will give us the measure of angle C sub 2. So 180 minus 107.260 minus 64, and that comes out to 8.740 degrees. So we have that. Now, we need little c. So again, we would go right back to the sine of 64 degrees over 16 as one side of our proportion because that was information that was given to us. And then we'd say, all right, I need little c, so this has to be the sine of angle C, which again should be perfect in your calculator right now. You shouldn't have done any rounding with your calculator, so you should be able to use that as you do your computations to figure out C sub 2. So this will be 16 sine of 8.740 degrees divided by the sine of 64 degrees, just by cross multiplying. And we plop that in. Again, you'd start with the computation you already have in your calculator, hit sine, second answer, then take that times 16, and then divide it by the sine of 64 degrees, and you'll have 2.705 for C sub 2. And again, like I said, stop and take stock. I'm probably not going to do this for all of these, but it just is really helpful before you turn in a test, before you turn something in to know, hey, I found all of these for both triangles. So a sub 2, that didn't change. That was still 16. B sub 2 is still 17, but pretty obviously our little C sub 2 is now 2.705, along with some changes that we had for the two angle measures up here, where the measure of angle B sub 2 was 107.260 degrees, and the measure of angle C sub 2 was 8.740 degrees. So we've got them both. You know, and again, I included that step of checking to see, should we really have two solutions? So I'm going to do that again with number 20. So number 20 gives me angle B, and then the opposite side, little b is 21. And I want to place that C value over here so that I will have angle side side, because I have to have that. I mean, they flat out told us it's two triangles, but if I would want to figure out whether or not this does have two triangles, that's the way I have to place those, because our choices for the use of law of sines are angle, angle, side, angle, side, angle, and side, side, angle, where we have the ambiguous case. So those are the only choices that we have. So this tells me the big C is going to be here, big A is going to be here, little a is going to be here, and the first thing I want to do is find the height. So drop that perpendicular down and say the sine of 38 degrees will equal h over 25. So h will be 25 times the sine of 38 degrees, and that will give me, that came out to 15.391 for h. So 21 is definitely bigger than 15.391, but 21 is definitely smaller than 25. So absolutely, this is going to work. So B is greater than H, but it is less than C, and that's what we have to watch for. Again, the letters don't matter. What matters is the relationship in that angle side side setting. So let's go after the big triangle. So we will have the sine of 38 over 21 as our staple. That's the large angle B, and then we've got our side opposite that, which is 21. And I have a 25, so that means I'm going to have to go after angle C. So we cross multiply, and we would have 25 sine of 38 degrees over 21 equals the sine of C. And then, of course, because we need an angle, we're going to have to use the inverse trig function to get that. So we would punch in 25 sine of 38 degrees over 21, and that is not the most readable thing I've ever written. There we go. And the measure of angle C will come out to be 47.133 degrees. And then every triangle has 180 degrees. So we would go back and say, all right, what do we have so far? Well, we've got 180 degrees minus 38 from the given angle, and then we'd subtract the one we just found, which is 47.133. So the measure of angle A will be 94.867 degrees. And again, we're going to keep using that pair of angle and side opposite that they gave to us. Sine of 38 degrees over 21 equals. But now if I want to figure out what side A is, I'm going to have to go ahead and use something that I had to figure out. So that's the sine of 94.867. We would cross multiply and divide in order to get A all by itself. And then we go ahead and crunch that in. Again, you'd have that answer already in your calculator is perfect. So you could punch in sine of the answer times 21 and divide by the sine of 38. And little a is approximately 33.987. So 33 38.987. And now we have to go back and get our sliver triangle. Because again, what's going to happen here is this length will allow us to swing this back over and intersect the base of that triangle again. And that sliver of a triangle will also be formed. So B sub 2 is going to be 38 degrees, but we need to figure out what C sub 2 is and A sub 2. But this is still 21 and this is still 25. So the key again is the fact that this is now an isosceles triangle, and we found what we wanted that angle C to be. That was our 47.133. So getting our angle C sub 2 is just a matter of subtracting that from 180. And that's because we have a supplementary relationship there, because that's a linear pair that is formed at that position. So we would say the measure of angle C sub 2 equals 180 minus 47.133 degrees. So the measure of angle C sub 2 is 132.867 degrees. And away we go at that point. You know, the math gets much easier because all we have to do is say, well, every triangle has 180 degrees. I'm going to take 180 minus the 38 that I already have, minus the 132.867 that I have there. And that is going to give me a measure of 9.133 degrees. Then what we do is figure out that last missing side. So the sine of 38 degrees over 21 equals the sine of 9.133 degrees over A sub 2. And we could go ahead and cross multiply. So we will have 21 times the sine of 9.133 divided by the sine of 38 degrees will give us A sub 2. And that's just a matter of punching it in. Again, try to keep things as exact as possible as you're working through it. So 5.414 for A sub 2. As I said before, I'm not going to write those summaries on these. You saw me do that in the first one. So I'm just going to go ahead and get to the next problem, which is number 21. Two triangles can be formed using the given measurements. Again, solve both triangles. And one more time here, I realize that I want to set this up with that angle side to side. So my C is 68 degrees, little c is 18. And because I need that angle side-side relationship, I'm going to have to put A equals 19 right there. So first step would be making sure that we're going to have two triangles by dropping down that perpendicular, finding that height. The sine of 68 degrees equals h over 19. So 19 times the sine of 68 degrees equals h. And we will get a height in this one of 17.616. And 18 is bigger than the height, 17.616, and it is less than 19, so we absolutely will get two triangles out of that. So we go back and we start finding all of the missing information, and we realize this is going to be a capital A, and that makes this a capital B and this a little b. So we go with the one they gave us, which is the sine of 68 degrees over 18. And we would use the fact that we know 19 to figure out angle A. So you do your cross multiplying, you have 19 times the sine of 68 degrees over 18 equals the sine of A. And you recognize that we're finding an angle, which means we need to use an inverse trig function. And you just carefully punch that in, and we get 78.152 degrees for the measure of angle A. And once we have that, we know every triangle has 180 degrees, so we'd take 180 minus 68 minus what we just found here, and we would have the measure of angle B at 33.848 degrees, which of course we needed if we were going to figure out what that last side length that we have there, that lowercase b is. So back to the left side of our proportion again, but now we have to use some information that we found to figure out what is lowercase b, that last side length. And that will give us 18 times the sine of 33.848 divided by 18 for b. Oops, not divided by 18, sorry, divided by the sine of 68. There we go. And carefully punch that in, and we have b as 10.813. Now back for the little sliver triangle. So what we have right now is our little sliver triangle where we have 68. This will now be c sub 2, b sub 2, a sub 2. C sub 2 will give us 18, a sub 2 will give us 19, and we're going to need to find b sub 2. So how we figure out what to do is by remembering that whatever we had for angle A up here is now going to be supplementary to our angle A sub 2. So here's what we need to do. The measure of angle A sub 2 equals 180 minus 78.152 degrees. That makes the measure of angle A sub 2 101.848 degrees. Once we have that, every triangle has 180 degrees, so we'll go back and say, all right, let's find the measure of angle B sub 2. I've got 180 minus 68 minus 101.848, and that's going to be 10.151 degrees. And now we're on a roll, so the sine of 68 over 18, again that's our staple because that was information that was given, equals the sine of 10.151 over little side b sub 2. And 18 times the sine of 10.151 divided by the sine of 68 degrees, that'll give us b sub 2. And we grab a calculator and we get 3.422 for b sub 2. Now, all three of these that you've had me do so far, you probably were able to do them after we had finished the example that we did in class. Then, number 36. On the directions up here say in exercises 27 to 36, respond in one of the following ways. Cannot be solved with the law of sines. B, no triangle is formed. C, solve the triangle. So those are the things that we're supposed to be able to find if we know we get a triangle. So for 36, here's what it says. It says capital C is 65 degrees. What I absolutely know is that lowercase c is opposite that side. And then it says A is 19 and B is 22. So I can just kind of pick where those go. I'll make this one B, and I'll make this one A. Well, now I'm in trouble. And here's why. In order to use the law of sines, I have to be given this information. If I'm not given that information, then it can't be solved with the law of sines. I'm not going to be able to do it. So I take a peek at it and I think, well, I have, this is side, angle, side. It's not on the list. We cannot use the law of sines for this one. So it cannot be solved with the law of sines. Doesn't mean we maybe won't get a different way to solve it in the future. It just means that for using the law of sines, this is out. This does not fit what we need.